12.1 is called Exploring Solids. There's not going to be a lot of things as far as notes go that you're going to be able to write down today. Because when you talk about solid shapes, they get kind of difficult to draw. Okay, so you're talking about three-dimensional things now. In the past, we've been doing two-dimensional with octagons, hexagons, pentagons, squares, rectangles, triangles, things like that. All flat on the board, right? Now we're going three-dimensional here. Okay, so we'll get, in this chapter, we'll get to like surface area, volume, things like that. But before we get to any of that, we have to first understand some terminology. The first term we have here is polyhedron. Again, I'm not going to write this down. A polyhedron is a solid made up of polygons. So all the faces are polygons. What is a polygon, though? Not a circle, I agree with you. Okay, all edges have to connect. It cannot have any curved edges. And the edges cannot cross. Okay? A cylinder is not a polyhedron. A cone is not a polyhedron. A sphere is not a polyhedron. Is a pyramid. Yep. Yeah. Okay, or a rectangular prism. Yes. Okay, those are polyhedrons. Okay, you just have to ask yourself when you look at it, is each side or face a polygon? If the answer is yes, then it's a polyhedron. If the answer is no, then it's not. Okay? Thank you. Alright, I'm going to attempt to draw a rectangular prism. You art people, don't laugh. For the record, this is the worst one I've drawn all day. Could be worse. Could be like what Carson's going to draw on her paper. Just kidding. Okay, so you guys get what I have trying to go on here. So I have a rectangular prism here. How many faces does that have? What is a face? Like the flat surfaces, right? Or like the the polygons. Okay? So when I'm looking at the faces, I have one in front and one in back, right? For two. And then I also have the four going around, right? For four more, which is going to give me six. You have the bottom, the top, and the two sides. Okay, so I have a total of 6 faces. How many edges? 12. Which an edge is like this, right? So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Okay, so I have 12 edges. And what is a vertex? Yeah, good. The points, right? How many vertices do I have? I have 8. Okay, we could count those, right? Okay, I'm just making sure you know what they are. Okay, so as long as we understand what a face is, what an edge is, and what a vertex is, you should be able to count those up. Okay, let's take a look at example 1. Laney, part A. Is that a polyhedron? Yes, it is. I agree with you. Amanda, how many faces? 5. 3 going around and 1 on each end, right? Okay, Seth, vertices? 6 vertices, Matthias, edges. Nine, good. 3 going around, 3 on the right end, 3 on the left end, right? Okay. Part B, Paige. Is that a polyhedron? Why? It's got a curved side, good. Okay, part C, Taylor Stokes. Polyhedron? Yes. And part C, Gavin. How many faces? 7. It's got 6 going all the way around, right? The sides going up, and then the base. So that's 7. Taylor Hart, faces, or I just asked faces. Edges? Edges. Edges, sorry. 12, good. Again, 6 going around, but now it also has 6 connecting on the bottom, right? And Vincent, vertices? 7. 6 on the bottom, and then your point up top. Okay? Alright, flipping the page. Regular and convex are the next terms. The nice thing about those is we already know what they mean. What does regular mean? All the sides are the same length, right? So everything is congruent. That made more sense when I was talking about like a hexagon. These sides are all the same, right? So let's say I have a hexagonal base on a pyramid. Okay, so just like that last example we just looked at. To be regular, do the sides going up the pyramid have to be the same length as the sides on the bottom? Yeah. Yes. Okay, so that's where people get confused. They look at this and they're like, oh, well, that hexagon is regular, so it must be a regular polyhedron. Okay, that's not true. The only thing that's going to make this regular is if the parts going up are also the same length. Everybody good with that? Okay, so let's take a look there. Oh, missed convex. What's convex? It stays out, right? It does not cave in. Caving in would be called concave. Example 2, part A, they say it's convex. Do you guys agree with that? Okay, there's nothing that cave in. And they say it's regular. So is every edge the exact same length? Looks like, looking at the tick marks, it is. Okay, now on part B, it's still convex, but why are they saying it's non-regular or irregular? Okay, so that's what we were talking about, right? The hexagons on the top and the bottom are congruent, right? And those are regular. But the edges that go from the base to the top base are not the same as the others, correct? You guys get what I'm saying? Everybody see how the ones going vertical are longer? Okay, that makes that an irregular polyhedron. Is it still a polyhedron? Yes, it's just not regular. Okay, part C. They say it's non-convex, or we would call that concave. You guys agree with that? Everybody sees how that caves in. And they say it's irregular. Okay, you can kind of just look at that one and see that none of the sides are the same length, right? Okay. Well, some of them might be, but not all of them are the same length. We doing okay so far? Yeah? Can I get head nods at least? Okay. I know there's not a lot to write down, so it's a little bit different than a lot of our lessons. Okay, the next thing we have is called a cross-section. A cross-section is when you cut something in half and you look down on it and try to figure out what shape that is. Okay? So they use a sphere, which is like a ball, right? And I wish I had one in here, but I don't at the moment. If you cut a sphere in half and you look down on it, what shape is the cross section? It's going to be a circle. Okay? So that's what we're looking at. Now, what if I took this container here, cut it in half this way, look down on it, the cross section is a circle. What if I took this container, cut it this way, and look down on it? Rectangle. Okay, so just when I look at this, I think this is, I would consider this round. Right? Now, it's obviously not just a straight circle, but I would consider this pretty rounded. Does that mean it has to be a rounded shape when you hit the cross section? No, because we just cut it in half this way, and it makes a rectangle. Okay, so just understand that. Your cross section can change quite a bit from what you think it might be. So looking at example 3, they take a cube, and they they apply a cross section horizontally and create what shape in purple? A square. Now they also cut it diagonally once on part B and create a pentagon. Now, is it a regular pentagon? No, but it still has 5 sides, right? Okay, so it's still a pentagon. And then on part C, they just cut the corner off, which ended up creating a triangle. Okay, so you're going to have to look carefully at some of those. Some of those are going to be a little bit tricky. Okay, so look carefully. Be careful as you're going through those. Take your time. Don't rush through that. Okay, on the next page on 721, goal 2. I know we're kind of breezing through a lot of this. Okay, but stick with me here. I think your assignment will make quite a bit of sense. They talk about platonic solids. I don't expect you to memorize the 5 regular platonic solids. Okay, I don't expect that from you. I do expect that. I do want you to know where to find them if they were to ask you. Okay, so 12.1, you can go back and find those, hopefully. Okay, your platonic solids are your regular tetrahedron, a cube, a regular octahedron, a regular dodecahedron, and a regular isocahedron. You've talked about all of those sides except for the last one, which is 20 sides. Okay, you've talked about tetrahedron, which is actually made up of triangles. A cube is made up of squares. An octahedron is made up of octagons. Your dodecahedron has 12 sides. Okay, your regular isocahedron has 20 faces. Okay, so that's telling you how many faces they have. 4 faces, 6 faces, 8 faces, 12 faces, 20 faces. Okay? Again, I don't expect you to memorize that, so don't worry about that a whole lot. Okay, what I do want you to take off of that page is Euler's theorem. Yes. Euler's theorem. What this is going to allow us to do is, if we know how many faces and edges there are, we're going to be able to find the vertices. If we know faces and vertices, we'll find the edges. If we know vertices and edges, we can find the faces. Okay, without having to count. Because if you were to take a look at that dodecahedron or that isocahedron, that's not going to be very fun to count sides or faces, vertices, and edges, is it? No. So you're going to be able to use Euler's theorem here to solve something like that out. This theorem tells us that the faces plus the vertices is equal to the edges plus 2. Faces is the F, vertices is the V, and edges is the E. Okay, so faces plus vertices equals edges plus 2. Now, that's probably the easiest equation we've ever done in here. Okay? That doesn't mean it's going to be the easiest to come up with what to plug in, but that's just adding two things on the left side and adding two things on the right side, right? Okay, so it's the easiest one, okay, but we got to come up with some of that information is the challenging part. So, looking down, we're on example 4. Okay, only got 2 more examples for you, and then we're done. Okay, but example 4 says that I have a solid with 14 faces. Okay, it's got a total of 14 faces. 8 of those faces are triangles, and 6 of them are hexagons, octagons. Thank you. Eight triangles, 6 octagons. I want to know how many vertices it has. Okay. They gave you the diagram at the right there. Is that going to be very easy to count up? No. So what we're going to do, let's go ahead and start plugging stuff into Euler's theorem. So I already have 14 faces. I know that. So I have 14 plus, what am I trying to find? Vertices. So that's going to be my variable, right? Because that's what I'm trying to solve for. Equals my edges plus 2. Now the catch is that I don't know how many edges there are. Anybody got a guess as to what we're going to have to do? Okay, so we're going to figure out how many edges are on the octagons. How many edges are on an octagon? And I have how many octagons? So I have 8 edges and I have 6 of those, which is, okay, how many edges does a triangle have? And I have 8 of those for, so I have a total of how many edges? What's that? Yeah, so they share sides, right? Okay, that's where the catch comes in. Okay, a lot of you probably could have figured that out. Now the catch is, let's say that both my hands are rectangles, okay? And I'm trying to form that rectangular prism we started with. Okay, so I got to chop my fingers off a little bit. Okay, but this is an edge and this is an edge, right? So I have how many edges? 2. But when I combine them, now I have 1 edge. So I'm going from 2 to 1. So what do I need to do to this number to give an accurate number of edges in the end? What'd you say? Okay. I get what you're saying. I don't agree with you, but I get what you're saying. I'm going to divide it by 2 because each edge is going to connect to how many other edges? Right, but each one is going to connect to one other. So I'm not going to take 3 edges and combine them into one place, right? I'm just going to take 2 and combine them into one place. Does that make sense? I get what you're thinking, though, with the 3 edges on the triangle. I get that. But each edge is going to combine with one other one. Okay? So I need to divide by what, Carson? 2. And I get 36. That's how many edges I have in my actual shape. So here I have 36. So I have 14 plus V equals 38. V equals 24. Good. So I have 24 vertices. Is that easier than sitting there and counting up all of the vertices? Yeah, probably about 20 times easier, right? And super faster. Super faster. That doesn't even make any sense. Super better. Much faster, alright? There's a reason I don't teach English. Okay? I don't even know where I was going with that word, super. Much faster. Okay? Everybody agree with that? Yeah. Don't agree with super faster, but agree with much faster. Alright. Last example. Example, I think 6 maybe. We got a soccer ball. A soccer ball resembles a polyhedron with 32 faces. Okay? On that soccer ball, 20 are regular hexagons, so I need to take 20 times 6. And then that means 12 are pentagons, so 12 times 20 times 6 is 120. 12 times 5 is... So I have a total of... Is that the number of edges I have? I got to do what? Good, divide by 2. So I actually have 90 edges, right? Okay, so Taylor Arnett, can you set the equation up for us real quick? Close. Plus V, right? Which is 92, right? Yep, good. So how many vertices do I have? Anybody? 60. Okay. Can we do that? Okay, now I do want you to be careful. There is a portion of your assignment that says find the numbers of faces, edges, and vertices, and then verify it using Euler's theorem. Okay, so let's say I had 4 faces, 5 vertices, 7 edges. Just plug it into Euler's theorem, show me that you did that, and these should equal the same, right? So if you were to happen to get, I don't know, 6, maybe you got 6 and you got 8 there. That means you probably did something wrong, right? Okay, that's what they want you to do. They just want you to verify it using Euler's theorem. So you should, when you plug it in, you should be able to show me on your paper that they equal the exact same thing. Can we do that? Yes. Okay. Any questions? Okay, what makes a polyhedron?
Polygon.
It's made up of polygons. It has to be made up of polygons to be a polyhedron.